Good morning, everybody, and welcome to February's edition of Hackster Impact Spotlights. This is a monthly free virtual event where we bring you a number of presentations from Hackster community members sharing their projects and the tech that powers them. Each month we have an interesting theme. This month's theme is fitness tech. So we'll be exploring 3 different projects. We've got Whitney Knitter and Justin Lutz and Mario Berger on. We're going to learn about human pose detection with yoga using AI, and we're going to learn about climbing assistive tech, as well as TinyML rowing machine coach. So stick around for those in a second. We also even have next month's spotlights already getting started here. So we have a sneak peek of the design for that. Oh, it's actually gone away. But, well, you can go to our website, which may have been what brought you here today. Check it out. You just go to events.hackster.io/impact spotlights. You can see more about today's event and what's going on with that, as well as future themes. So on March the 27th, we have smart home technology coming up for you. You can just scroll down there. And you can see our previous month's themes and watch all of our segments from those. January was asset tracking, hosted by the inimitable Jesselyn of the Hackster team. And then we've got previous ones that you can check out below. Be sure to watch all of those. Sponsored by our awesome partners. So at the end of today's session, we will be sharing the links to today's project in the chat, and also we'll be adding those to the video description. So if you scroll down right now, you'll see some very basic information, but if you're watching the replay, you'll be able to just click over to these. And then also be sure to RSVP so that you can get update emails about future events. All right, I think we're about ready to kick this off. It's exciting to see some people in the chat already. Be sure to drop your questions in there. Although actually, we don't have live Q&A from our presenters, but if you have any questions around the program or future themes or anything like that, there's some things we can share, there's some things we can't, but I'm happy to entertain your questions and comments anyway. All right. Without further ado, our first presentation is from Whitney Knitter, and it is called Practicing Yoga with AI, Human Pose Estimation on the TDA 4VM. And I already watched a bunch of this, and it's very interesting, so let's hit it with Whitney.
Hi, my name is Whitney Knitter, and I run an engineering tutorial blog called Knittronics. And for the past couple years, I've been working to use AI to develop an application to help me with my yoga poses. A little bit of backstory. Obviously, because I'm an engineer that spends lots of time on the computer, my poor back and neck from poor ergonomic posture pays the price. So I decided to take up yoga as a way at the end of the day to kind of stretch and help with said back and neck issues. What was really funny was as I learned new poses and was practicing, I thought I was doing really well. And I don't know why, but for some reason I decided to film it the first time just to see what I looked like. And it was absolutely hilarious how I felt like I was holding a pose so perfectly and well.
Go. Get it! You did?
The perfect cartwheel.
Okay, good.
And then when I watched the video back, I was nowhere close to being in the right position. So engineering brain kicked in and wanted to find a solution for this. How can I close the gap between how I feel I'm holding a pose and am I actually in the correct pose? Because I'm not going to go to a yoga studio, I'm going to figure it out myself. So at first I got an idea. I saw what was called, they were called flex sensors, and they're just like these little, they look like flat flex type connectors that I was thinking about putting them in like the crook of my arm or any other place that my body bends. And essentially it's just like a flat little device, and it outputs different voltages. It appears to be a different load whenever you bend it a certain amount. And my thought process is I could, putting those in the different places on my body that bends, I could calibrate like, well, for this position, this sensor should be outputting this voltage or appears this load if I'm in the right pose. And I went down that route And obviously, where it got kind of messy was trying to attach all of this to my body and then have it all feed back to like a particular processor. Did the processor need to be attached to my body? How do I power it? And it turned into a mess. That's when I noticed, because machine learning and AI applications have become so prevalent in the engineering world, that's when I saw the human pose estimation models out there. Now, as someone that has been in the engineering world for a little while now, I'm old enough that machine learning and AI development or classes weren't even an elective option yet when I was in my undergrad and graduate schooling. So that's why it wasn't necessarily my first thought, and it's something that I need to teach myself from scratch. This led me to looking into all of the options for pre-trained models, because taking a pre-trained model versus developing your own algorithm, training it yourself, that's a lot to take on for someone that's new to the whole world. And if there's something that 10 years of being in the engineering space has taught me, is if I start a project too complicated, I'm never gonna get it done. So I started looking at who offered pre-trained human pose estimation models, and they all seem to be based on YOLO-X is the acronym for it, particularly with the COCO data set and what's called COCO key points. So COCO key points are it's a trained machine learning algorithm that is specific to identifying different joints on your body, like your eyes, your nose, your elbows, and everything. And then the actual machine learning model, it takes the image data, finds the key points and all the joints on your body, and then just draws lines. So you end up with, you give it an image or a data stream, and it draws a skeleton on your body. Because I have this skeleton on my body, my thought process was then I could apply basic geometry to that skeleton in a post-processing algorithm to then calculate the slope between like this part of my arm and this part of my arm for each individual pose. And so like if the pose needed my arm to be like this, I could calculate this slope compared to this slope, and on my post-processing algorithm, I know if the pose is right. So using the TDA4VM chip from TI on its development board with their Edge AI Studio, I was able to utilize their pre-trained YOLO-X model with the Onyx runtime to create this Jupyter notebook, where I defined my pre-process for the Onyx pose estimation model. Specifically, this is mostly just resizing the image to be the size that the model was originally trained on and is therefore expecting. And then I'm able to, here I call the actual pre-trained model to run inference on the new image that it just took of my yoga pose. I don't know why I put that in air quotes, but probably because it's so bad. And then after it runs inference, it draws my little skeleton on it. And so far, because I'm still determining what the actual slope of each line on the skeleton needs to be, I'm just having it print out each individual slope. The other thing that's really helpful about this particular human pose estimation model is it also color codes each part of the skeleton depending on what part of my body it is. So as you can see here, it color coordinates my arms and shoulders as blue, my head and neck area is green, body is magenta, and my legs as orange. So I was simply able to go to my post-processing algorithm, and this is where I added, for right now, just sectioning off each individual part of my body and saying this is the actual slope for each part of that skeleton. So now I just need to go back through and take through, you can see I've captured a bunch of data to train here of different poses and uploaded it here. So I just need to go through and figure out what slope for each of these different poses needs to be relative to each other. And once I do that, I will be able to add on to my post-processing algorithm here. I'll probably have it output some sort of auditory cue still, Probably something funny, something for a good pose or a bad pose. I should have it boomy for a bad pose. That would be really funny. So that's how I'm using AI and machine learning to solve my poor yoga posture, which is ultimately a solution to my poor desk posture. Anyways, thanks for watching and don't forget to stretch. Bye.
Awesome. Yeah, I'm gonna have that stuck in my head for the rest of the day. I love her sign off there about don't forget to stretch. Honestly, I should stick that at the end of all our videos to like hack on and don't forget to stretch because I always do. But anyway, our next presentation is from Justin Lutz, talking about Arduino Row, your TinyML rowing machine coach, and this one is based on the Arduino Nikla Sense ME, which is a very smart little device, about yay big, like the size of a postage stamp, that has IoT capabilities, and it's got all kinds of cool stuff, built-in sensors and such, and Justin is using it with the Arduino Cloud app, which includes an IoT remote option, which allows you to interface with your Arduino stuff over wireless. Let's check it out.
Hello, everyone. Welcome to the Hackster Impact Spotlights for 2025. My name is Justin Lutz, and I'm really excited to talk about my project for today. I call it Arduino Row as a play on Arduino. In this case, I used Arduino hardware to develop an Edge AI solution as a personal rowing coach. So before I get into my project, a little bit about me. I got my bachelor's in computer science about 25 years ago now. After I got my bachelor's degree, I went back to school part-time and got my master's in business administration. I'm also retired from the United States Reserves, military reserves. I started out as an enlisted Marine reservist and retired about 3 years ago now as a U.S. naval officer. I'm currently a quality director at Raytheon. I've been with the company for 23 years now, and I started out as a software engineer, and I've been in quality for about 15 years now. In my spare time, I'm an AI ML hobbyist. I like to do projects using microcontrollers and single board computers. I'm also big into astrophotography and do that when I have clear nights where I live. And the last point for why this project exists, I'm also a former competitive runner. You can see a photo of me there running the 3,000 meter steeplechase race. For those of you who are unfamiliar with that race, it involves jumping over barriers. One of them has a water pit behind it, so it's a very fun and interesting event. I ran up to 100 miles per week. For those that are metric, that's about 160 kilometers a week. So I put a lot of wear and tear and stress on my body over the years, which is why I wanted to do this project. So, looking at the project after years of running, I really needed to cross train more. I had a series of injuries where I just couldn't maintain the level of running that I did in my younger days. So I found that stationary rowing to be a good alternative to running. It's a really good workout, but it's less wear and tear than being on your feet. So combined with the Edge AI hobby that I have, I developed a virtual coach that evaluates your rowing cadence and form and provides real-time feedback using the Arduino IoT cloud. I also collected environmental data. In this case, it was carbon dioxide readings, just to provide that information to the rower, see if there's any change in carbon dioxide while you're rowing, because elevated carbon dioxide can create an unsafe environment, especially indoors. All right, so what did I use for this project? It's very simple, really. Just a couple pieces of hardware. Primary sensor is the Arduino Nikla Sense ME. that has both accelerometer capability as well as environmental data readings. So I thought that was a valuable um, piece of the puzzle for my project. I used it as a shield on top of the Arduino Maker Wi-Fi 1010, and we'll get into that later on why I chose that in my decision making for the design. And then very simply, I just use a lithium-ion battery. You can see a battery connector at the bottom of the Maker Wi-Fi 1010, and I just connected battery to it to provide power. And then I just used the breadboard to provide some stability so I could tape that to the rower handle. Really a very primitive design, but we can talk about future capabilities in later on in the presentation. And then for software, I used Edge Impulse Studio to develop the model, the Edge AI model. And then I used the Arduino IoT Cloud to create a little application to give you that real-time data. And then I did all the coding within the Arduino IDE. All right, so I chose the Nikla Sense ME, as I mentioned earlier, because it has both an accelerometer and environmental sensors. Um, The one drawback, which is why I had to use the Maker Wi-Fi 1010, is that the Nikla Sense ME only has 64 kilobytes of RAM. So I found that as I deployed my Edge AI model to the microcontroller, that it would crash due to running out of memory. I didn't really feel like trying to optimize or try to disable packages within the MCU board itself. So what I did was there's the option to use the Nikla Sense ME as a shield on another MCU. And that's what I did in this case. So I used the Maker Wi-Fi 1010 as the MCU to mate the Nikla Sense ME to. So I found that worked pretty well. And not only that, the Nikla Sense ME only comes with Bluetooth. So I would have had to create my own app through MIT App Inventor or some other way to read the data or display the data. With Wi-Fi capability, I can now use the Arduino IoT Cloud, which gave a great basis for starting an application and it made developing the app really simple. All right, I used the Edge AI. I used Edge Impulse to develop my Edge AI model. Edge Impulse is my go-to for developing any of my Edge AI models. It's very simple, very intuitive, but provides really great capability. So I used their command line tool to directly input the accelerometer data from my MCU. So I just hooked up a USB cable from the MCU to my laptop, and I could directly load the accelerometer data into the Edge Impulse environment. So it made it very simple. And then I used that data to train a model, very simple time series data neural net classifier. And I did 3 states, easy, low strokes per minute, and high strokes per minute. And I found that with that model type, I got really great accuracy. So there was really good grouping between the 3 different states that I had done for my model. And if you want to this is just a really quick overview. If you want me to get into more detail, you can see it in my Hackster project write-up where I really get into the details. So feel free to explore that if you want a little bit more detail. All right, after I had trained the model, I exported it as an Arduino library and just integrated into my code. And again, Edge Impulse does a really great job of making it very simple and straightforward, as much as possible anyways, to deploy the model to whatever environment you're developing in. And Arduino is particularly straightforward. So I have a little bit of a code snippet right here. You can view my full code sample on my project file again. But here's just a little snippet of reading the accelerometer data, filling up a features buffer based on the sampling size that you select. And then once that features buffer is full, you develop a signal from that, and then you run the classifier. So it's really straightforward. And then once you get the inference, you just implement the logic based off of the inference result that you get. And on the right, you can see the IoT cloud interface. Again, I thought this was very straightforward and very powerful. Uh, it's really scalable to whatever you want to do. In my case, I just set up basically like a text chat that provides text messages in real time based off of how you're rowing. And it also provides CO2 levels as well. Again, to alert the rower if the air quality is getting dangerous. All right, so I have a video here. I'm not going to play the full video because it's several minutes long and I only have 10 minutes. So I'll just play a little snippet so you can see it in action. You can see the application on the right and you can see me rowing on the left. And all right, stand by for a quick demo.
Hi all, Justin here with the Arduino Row application with Arduino and Edge Impulse. So you can see I hop on the rower here, start off at an easy pace, and the app should reflect that. Yeah, it says push with your legs. So I will start to add some more power to my stroke by pushing harder with my legs. You can see I do so right there. That will change the state of the app. There we go.
All right, so again, you can see the full video on my Hackster project write-up. So feel free to check that out if you want to see the whole video. And I go through the range of changing my pace, and you can see how the app gets updated based off of the how hard I'm pushing or how easy I'm going. So I think it's pretty neat.
Hi all.
All right, so looking at next steps, so certainly developing a 3D printed case would be a good first step. You could see earlier in the presentation, I really just taped a breadboard to my rowing handle. So certainly developing a case to make it more aesthetically pleasing, I think would be a good next step. I'd also like to look at additional functionality. Currently, I just read the CO2 levels, but I could also look at reading temperature, humidity, and also IAQ data. The Nikola Sense ME is able to provide all that information. So you can look at other environmental data to see how that changes during your workout. Obviously, as it gets warmer and more humid, your effort it becomes more difficult at the same pace. So, it can provide feedback such as, it's getting really warm, really humid, slow it down a little bit. So that's one thing that I think I could work on as well as the anomaly detection algorithm to detect if the handle is being pulled before the leg press is complete. And that is really just enforcing good rowing form based on the accelerometer data. So I think there's an opportunity there as well. That concludes my presentation. I really hope you enjoyed it. You can check out the project. Again, I have the full write-up there. I have all the code, and I have the full video there, so you can check it out at your leisure. I post all my projects on Hackster, so you can look at my Hackster profile as well to see other projects that I've done. And you can also find me on LinkedIn. So hope you enjoy this, and have a great day. Bye.
Awesome. Great presentation. I love to see a good enclosure, so I'm excited to see that in the next steps from Justin. Really interesting project that he had going on there, especially the CO2 measurements in the room, which is not something that I often see in these fitness tech projects, but makes a lot of sense. Honestly, it's something that also I think would be really helpful in like conference rooms. People are biological beings, and time again, I'm reminded of the fact that like if we're in a meeting for a long time with closed doors and closed windows and stuff, like our brain capacity actually goes down. And I'm sure like with exercise, your exercise capacity as well as your brain functioning goes down like as the CO2 accumulates and like oxygen gets low and stuff. It's fascinating. Anyway, we're not here to dig into that. We do have one more talk for you from Mario Bergeron, who is a member of Avnet's TRIA team. This is a brand within Avnet focusing on producing embedded compute boards, so it does a lot of really cool stuff, and he's also published a bunch of projects on Hackster. Mario is going to tell us about detecting the mechanics of climbing with OpenCV, so computer vision. Very exciting. Let's have a look. Let me make sure I'm grabbing the right one.
Hello, Hackster community. Thank you for the invitation, Jocelyn. My presentation is called Applying AI to Climbing. My name is Mario Bergeron. I work for Tria Technologies as a machine learning specialist, and I'm mostly involved in embedded vision, so applications that have image sensors on embedded platforms, and more recently doing AI at the edge. So taking all these wonderful algorithms and trying to make them run on resource-constrained hardware. And when I'm not working, I'm a woodworker and a rock and ice climber, which is the motivation of this presentation. I've always had this curiosity to see what all these great algorithms could do when applied to my passion, which is rock climbing. And I think this presentation talks more about a journey than an actual finished project. As you'll see, sometimes when things aren't working, you wait a certain amount of time, and state of the art has a tendency to resolve problems that today are not working, may work in a year from now. And my motivation for applying these algorithms to rock climbing are mostly with respect to comparing the climbing techniques between me and my wife. We have different heights. She's 5'2", I'm 5'8". So oftentimes we go about the problems a completely different way. And I've always wanted to try to analyze that. So this is why I tried to apply these AI machine learning algorithms to rock climbing. So I think the event that sparked this is when rock climbing became an official sport of the Olympics. This was for the 2020 Olympics, which actually did not occur in 2020 because of the COVID pandemic. They occurred in 2021. And at that point, my expectation was, after seeing all the wonderful things that they were doing for other sports like soccer, overlaying lines on the fields and doing some 3D reconstructed playbacks, I was expecting to see something similar with the rock climbing field. So, for example, comparing two climbers. So I think in my case, I would start from just video files, so recorded footage, and then I would start by detecting the humans in the scene, so trying to detect the climbers. And if there was more than one person in the scene, at this point it becomes interesting or important to track each of these people so that we could, from one frame to the next, know which is the same person, so we could do further algorithms on this. And if there's many people in the scene, or sometimes even more than one climbers, we may want to zone in on one specific climber. So this would somehow try to isolate one of the climbers. And if we're doing comparison, we're doing this on many video feeds. And then finally, to do the actual comparison, we need to align the videos of where the people are on the route and then do the final comparison. So this is the paper napkin design, if you want, of the application. So I started by creating a simple use case where I did a manual side-by-side montage of two videos of my wife and myself climbing just as a first test scenario. But this is the simplest use case you can have because as you can see, each video has only one human in the scene. So there's no need to track and isolate the climber. There is only one person. But in more complex scenarios, we may have separate videos so they won't be manually aligned like I've done. They may have many people in the scene. So this is where the tracking and the isolating the climber of interest becomes important. So this is still, it's better to start simple and then work our way up in complexity. So this was my starting point. So in 2021, I tried the pose detection models on some of this climbing footage and was rather disappointed. I tried two of them, a two-stage model, SSD plus FPN, as well as a single-stage model, PoseNet. Could have tried YOLO as well. I don't think I did try YOLO at that time. But as you can see, the algorithms, both of them had a very hard time detecting a human, period. And when it did find one, it had a hard time actually identifying the pose, so where the arms and the legs were in the scene. So this was not very successful. And so this is the second one. This is PoseNet. But what was actually peculiar is as soon as the human being in the scene was touching the ground, the algorithms would work fine. So the problem wasn't the algorithm per se. it was the training data that was used to create these algorithms. So obviously, they didn't have human beings hanging from walls or from the roofs in their data set, which is why in this article, the second publication I called the odd human data set. So the use case of rock climbing just put human beings in unusual poses that were not part of any of the training data sets. So the algorithms were not working. So at this point, two options presented themselves. Either I created my own training data and retrain these models, or just wait for maybe the state of the art to evolve, and which is kind of what happened. But in 2021, I was at the point where I was not even able to detect the rock climbers. So that was not very encouraging. So I put the project on the shelf and waited a year. And then in 2022, I saw an article from Learn OpenCV showing how YOLO v7 was used to detect human beings in unusual poses. So this is a nice use case where the algorithm is having a time, media pipe pose detection is having a hard time differentiating the human from the horse, whereas YOLO v7 was doing a better job. So obviously you can see here not only the algorithm had evolved, but also the training data was taking more of these odd human positioning. So I said, I've got to try this on my use case. And lo and behold, it worked very well. Not only did it detect all the humans in the scene, but it also correctly detected the poses, so the arm and the leg positioning. So that was a good sign. So I tried it on a slightly more complex use case here, where we have two people in the scene. So in this case, you can see that I put the overlays in the middle portion just so that we could start seeing the comparison of the two climbers on the same reference point in the middle. So this started working pretty well. So here we were in 2022, finally able to detect rock climbers in the scene successfully. The next topic now is tracking. And the reason we want to do tracking is, if you look at this scene where I've got a lot of people in the scene walking in and out of the frames, you can see that the object detection networks are returning a bunch of identified objects, in this case are human beings, but with different IDs. And the IDs are not consistent from frame to frame. As you can see in the middle here, this is me climbing. Sometimes the ID will be 0, sometimes it'll be 1, sometimes 2, sometimes 3. So there's no knowledge of where is this same person from one frame to the next. So this is where we need to start looking at tracking. And these tracking algorithms are based on position in the scene, but also on similarity. So in this case, what makes this difficult is if I'm climbing and I fall, I'll actually change position quite a lot. Earth gravity pulls you pretty fast to the ground. So so I did try many tracking algorithms without success. And then in 2023, there was a fairly popular tracking algorithm called Deep Sort. This was the most promising candidate. But in this use case, once again, for rock climbing, as you can see on the right video, it's continually losing me as soon as I start moving or falling. So this is either because it's not able to distinguish me from the features of the rock, or it's confusing me with other people in the scene. But the main takeaway here is that Deep Sort was not working well for this specific use case. So here I was, 2023, able to detect humans in the scene, but not able to track them. And this is also, well, brings us to 2024, where we had the next Olympics, where I was expecting to see a lot of 3D visualizations of the climbers on the walls, but this did not happen. Although there were 3D visualizations of the static wall in the holes, which was pretty interesting, there was no actual replay of the climbers or any kind of comparison between climbers, which was kind of disappointing. But my prediction for the next ones in 2028 will be we'll start seeing this kind of side-by-side comparison and 3D visualizations of the climbers doing their routes. So will the Olympics achieve this goal before I do? I don't know. We'll see. Then at the end of 2024, not too long ago, I saw this new algorithm, which was called Samurai. It's actually a tracking algorithm. Um, its downside is it currently only supports tracking one object in the scene, but that is exactly my use case. I want to isolate one climber, so that's perfect for this use case. And it's doing really well despite occlusions, losing the object for a few frames. Like you can hear with the smoke, it knows after where it is again. You can see this person. So I said, okay, I definitely have to try this on my use case. And lo and behold, if you look at the comparison between, on the left, we have just the pose detection alone. In the middle, it's the deep sort, which is having a hard time following the climber. And on the right, it's the Samurai algorithm. And it's working perfectly, actually. So that is very cool. So here we are, in end of 2024, we're able to detect climbers, not only track them, but isolate the climber of interest. Things are going really well. So what would be the next step? I think instead of coding the alignment and the comparison, I think the next step would be starting to look at LLMs, and more specifically agentic AI. Here I'm showing an example that I just experimented with a bit from Landing AI, which is an online cloud service provided by Andrew Ng, a renowned specialist on machine learning. And if you see, we provide some video footage and a prompt. And so in this case, identify the climber, the rock climber of interest, track this climber, count how many times the climber falls, and determine if they reach the top. And then these agents come back with describing how they're going to tackle the problem. So I've generated code. I'm going to just find which climber makes it to the highest point and see if there's sudden downward movements. That'll be identified as a fall, et cetera, et cetera, et cetera. And then it provides the code that you could run. And you can see here on the bottom, it actually shows like intermediate results of tracking. And it turned out this algorithm, it did not use the Samurai algorithm I had identified, but it used the underlying SAM2, which is the segment anything model. And it wasn't quite working to my liking. So it was actually not counting any falls. So there's a few bugs to work out. But I think these are definitely tools that will be that I will experiment with to see if I make it further in this project. So if you found this interesting, if you want to dive deeper into the subject, you could follow. I have a project on Hackster describing this, or just follow me on my Hackster profile. That's it. Thank you very much.
Sweet. So I totally massacred his name earlier. Mario Bergeron, thank you so much for that presentation. Again, it was awesome seeing Mario's presentation because he works with the Avnet Tria team creating embedded compute boards, which do lots of cool stuff. I'm going to pull up some of our tabs again, and we're going to drop the links for each of these projects into the chat. We'll also share these in the description of the video. If you watch the replay, you'll be able to find these just by scrolling down on whatever platform you're on. Let's have a look. So, first up, we had Whitney Nair with Practicing Yoga with AI, Human Pose Estimation on the TDA 4VM, piece of Texas Instruments hardware. And you can check out Whitney's profile. She's got a ton of projects, 170 projects, more actually than me on this platform. She's just does a ton of interesting work with FPGAs and such, and she's got her own website that she mentioned, which is Nitronics. You can find out more on nitronics.com. Then we have Arduino Row from Justin Lutz, your TinyML rowing machine coach, based on Arduino technology, including the Nikla Sense ME, and also a Maker Wi-Fi 1010, and then also the Arduino IoT Cloud and Edge Impulse, which is a really useful tool for creating Edge AI-enabled devices. We've got his... I just noticed his profile picture there. It's hilarious. And he's also contributed a ton of different interesting projects, including kid-focused ones that are pretty cool. lots of interesting stuff to dig into there. Then we had Mario Bergeron with the mechanics of climbing, inspired by the Olympics. And actually, in his project, he links out to a number of really interesting in-depth blog posts on the Element 14 site about sort of like the backstory here and things like what types of poses you might encounter in the wild and need to detect for. He's also published a ton of projects on Hackster, including lots of stuff featuring Tria technology, as mentioned before, which you can find at tria-technologies.com to explore more of what's going on with that team. They're doing a lot of cool stuff, including with Monica Houston, one of the OG Hackster employees, and it's really cool to see her going further within Avnet. Shout out to Monica. If you want to see more cool projects around fitness, go check out the fitness community on Hackster, just hackster.io/fitness. There's always new stuff on here to check. And then also, of course, go to the Impact Spotlights main page, which I'll pull up here on a banner. It may be where you found us in the first place, events.hackster.io/impact spotlights. You can also get our update emails about future Impact events by going to this link, bit.ly/spotlights-RSVP. You'll get all the updates on different types of Impact events that we do. You can also check out all the previous recordings on our Impact Spotlights playlist, which is available on YouTube. You can see we're live right now. I'm not going to cause some kind of time stream tunnel by going into there, but it's already up there. We'll have the one for March up soon, which is smart homes. And actually, Jesselyn has helpfully dropped me the image for that. So I'm going to hide this, and we're going to pull up that image real quick because it's beautiful. Our designer, Courtney, is an incredible, she just has an incredible eye and makes these beautiful, beautiful things for each of our episodes. So here we go. Smart home tech for Impact Spotlights. That'll be next March, next 27th, a month from now on March 27th. So be sure to tune in then for a ton more cool projects. And then I think I had one more link. Nope, that was it. So be sure to go to events.hackster.io/impact spotlights to keep up with all the latest. Again, if you're joining us right now, check out the chat for the links to each project, or scroll down later on, and you'll be able to find those in the description to the video, along with some of the other stuff that I pulled up here. So thanks to Jesselyn for running things on the back end today, the whole Hackster team, including Courtney, for doing design, these beautiful designs. Let me just hide myself for a second. Can I show you what this background looks like? Doesn't matter. Anyway, thank you so much for joining us. It's really fun to see your comments in the chat, including some familiar faces. Be sure to tune in next month for Smart Home Impact Spotlights. And as always, hack on. And don't forget to stretch. What was it she said exactly? Don't forget to stretch, or stretch every day, or something like that. I'm